You out of
Go. I go to my class.
Oh, it smells. I can smell the peanut. Thank you.
It's not even like a script.
Okay. So jumping into still with radicals. Still with radicals, but now we are solving equations. So now once we do get that common denominator, I kind of talked about this yesterday, now we can just drop it because we're solving equations. Are we good with that?
Yeah.
Okay.
Go into the harder one.
So we only have 4 of them to do.
Oh, okay.
Yeah. So first things first, when you're trying to figure out whether or not you have common denominators or not, make sure you factor it. Don't go and give this one x squared plus 4x minus 12 because you're going to make your life way harder than it needs to be. Because when you factor something that's factorable, you'll probably realize that there's already at least a little bit, if not fully, an overlap, which in this case, the fraction on the right-hand side's got it all. The 3 just needs a denominator add-on of x minus 2.
I feel like this is harder. Like this is easier than last night's.
Yeah, definitely. Complex fractions is probably one of the harder topics. And the second fraction needed x plus 6. Now, every single denominator in this equation has x plus 6, x minus 2, so we can drop that. The only thing you want to remember is that if we get a solution, there's 2 solutions that if we get them, we have to reject them. What 2 numbers could we get that we would have to reject, Tommy?
2, positive 2, and negative 6.
Very good. Anything that's going to make a denominator 0, like negative 6 or 2, we have to reject that answer if we get it as an answer. And it probably won't even come up, but sometimes it does.
It's not even playing music, so I'm not even going to say that.
Oh, first of all, I don't care if it's playing music or not. Take it out of your ear.
Yeah, it feels nice.
So 3x minus 6 plus x plus 6 equals 4. And you're just going to solve that. You're going to get 4x equals 4, x equals 1. And that wasn't one of the ones that Tommy said we would have to reject, so that's your answer.
Being powerful.
All right, number 2, the second denominator here, x plus 1, x minus 1. The first denominator needs an x minus 1. Last denominator needs an x plus 1. And then we can drop our denominators and focus on the numerator. So in my numerator, pretty straightforward, distributing the 1. That's an x minus 1. The 2 didn't need anything, so equals 2. The next one you have to be careful on. Why? Right. You're subtracting 1 times a binomial. There is a binomial involved. So what you really should just do is distribute a negative 1. So that would be a minus x and a minus 1. If you just distribute a 1 and just put x plus 1 and just put a minus in front of that x plus 1 without having that x plus 1 in parentheses, you'd get it wrong, obviously. So from here, just solve. Add your x to the left. And your non-x's, I'm going to add that 1 over. Rock, you with me? 2x equals 2. Oh, we get x equals 1 again.
Yes.
Is that acceptable or rejectable?
I think we should have these ones up on purpose.
Rejected. Right.
Right, you would reject that. 1 and negative 1 are excluded values. So does anybody remember the vocab word, what kind of solution that's called? No, your answer to the problem would be no solutions. Extraneous, yes. So when you get a solution, and you didn't do anything wrong, you did everything right, and you get a solution that doesn't check out because of some weird kink, like a 0 in a denominator or a negative underneath a radical, it's called extraneous. So it's not a solution to the equation, but sometimes it's called an extraneous solution. Did they use that word in the Hills classroom? Extraneous? Yeah. Okay, good. All right, 3A and B are going to be obviously a little bit more challenging because you've got multiple variables. So we're still going to solve a rational equation the same way by getting variable, the denominator to be the same in every location. But then when we solve for p, we're not going to get p equals a number. We're not going to get p equals 5 or p equals 1. We're going to get p equals some expression that's going to be in terms of q and f. Does that make sense? You've done these before. So I don't know if you've done rational ones, but so to solve for p, it's a rational, get the common denominator all the way across. So, Allie, what does this denominator need? QF. And this one, Mike? PNF. Good. And this one, Ryan? This denominator is PQF. This denominator is PQF. And right now this is just F. So what? And
Oh, your P's and Q's.
They must use my Q's.
Yeah.
you with me? We needed a Q there. So PQF, 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 they're all done. So we have QF plus PF equals PQ. Now this is going to get a little bit tricky from here. And this might, I think my kids will remember when I taught this. I don't know if the Hills teach this type of problem. And I know Mrs. Ziggy, I don't know that. My advanced kids were a little bit mixed on whether or not she touched on it. But I'm trying to solve for P, and the issue is I have P's on both sides, right? Which normally if you had 7P on the left and 5P on the right, you would just move them all together and combine them, which would be nice and easy. Because these aren't numbers, I can't actually combine them. I can still get them on the same side, so you should still get all your P's together. So I'm going to subtract PF. PQ minus PF. But again, normally I can combine 7P minus 3P. What do you do if you can't combine them?
Yeah.
Good, so then they definitely did this.
Yes.
Good. So if you can't combine them because they're variables, you have to factor that. So pull out a P, and that's how you get there to be only one of them. So we just factored out a GCF of P essentially. But that's what we needed. We needed there to be only one P in the problem. You did this a lot when you wrote the inverse of rational functions is when this came up the most. And then P can become all by itself just by dividing that Q minus F over. And there you're done. How about, I know I only have 2 of you, so it's not a great sample, but Mrs. Ziggy's kids, does that look familiar? Debatable. Okay.
We spent the whole first half of the year with like a substitutes.
Oh, that's right. That's right. Any questions on that? And then the last one. If you're solving for B, there's like probably at least 2 or 3 different renditions of how you could do this. What would maybe your first step be, Carolina?
I want to say distribute, but I feel like that's very wrong.
No, it's not very wrong. That's definitely one way. I'm going to probably show you multiple ways, so I'll do the distribute way here. So distributing half of H, you'd get half of HA plus half of HB. Yeah. Keep going with that. Then what would you do? Solving for B. Remember, keep your eye on what you're solving for. So what on this right side should I get rid of next?
Would you get rid of...
Let me give you a technique. If you know you're solving for B, pretend everything else is a number. Pretend this is 10, pretend this is 20, plus pretend this is 5B. What would you do if you ever did have 10 equals 20 plus 5B? What would you do next?
Would you get rid of the 20?
Yes, right? So when everything is concrete in numbers like you're used to seeing, it's a no-brainer. Yeah. So if you ever need a technique to kind of guide you, just make everything else a number and kind of think through it. So if you would have subtracted this term, that's what you're going to subtract here. And then Faith, last step.
Well, I just get an A on the one side.
These are actually different A's. One's capital, one's lowercase.
Oh, so you would just divide by 1/2 H.
H. Now this is a little bit tricky because we don't really want to divide by a fraction ever. So if
Multiply by the reciprocal.
2, right. So you might, it's a little bit unnatural, but you might want to split that up into 2 separate steps. First, multiplying by 2, keeping in mind that this is a binomial over here. So when you multiply it by 2, you're going to have to distribute that. You're going to get 2a minus ha equals hb, and then divide by your h. That way we don't have a complex fraction. If we did what you wanted to do, it's not wrong, it's just you have to then tackle the complex fraction because you can't leave a complex fraction in your answer.
Right. Okay.
So it just makes it easier if you split that up into 2 steps. So you didn't have to distribute here. And again, distributing might have made that a lot longer than it needed to be, so I'll just show you quickly. If you didn't distribute, since that b is kind of in those parentheses, you might just want to divide away that half of h first. But same thing that we ran into in the last one, you don't want to divide by that half. So you'd probably multiply by 2 on both sides first to get 2a equals h times a plus b. Then divide by your h equals the a plus b. And now you just subtract a. It's probably, and you're done. Yeah, it can go either way. These answers look obviously quite different, but they're the same thing. If you take a binomial and divide by h, 2a divided by h will be that. ha divided by h will just be minus a. So they are the same thing. It actually, so it's probably, you weren't wrong to distribute. It just, if you see both ways, you see that it's probably easier to just not distribute. Okay, so your homework. Allie, can you pass this out for me? Please, thank you. What do we got?
What do you mean? How do you get outside?
Let's do
One, it's only.
Let's do
That's cool. Long games.
Here we go.
1s, 5s, and 7s.
Wait, what is it?
1s, 5s, and 7s. I wrote it up there. Well, I don't think her even answers are on the answer key. So I want you to be able to check your answers. 1s, 5s, and 7s.